Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're looking at section 8.4 and we're looking at log properties. Basically looking at sums, powers, quotients, products, and sum and differences. Alright, so we're going to start out with the product rule, which says the log of mn is equal to the log of m plus the log of n. For example, if you have the log of 9 times 27, that's equivalent to the log of 9 plus the log of 27. I haven't shown you how to change the base yet, so this is difficult to type into the calculator without a change of base rule. But if I just do it in base 10, you can see that the log of 9 times 27 is 2.3856, and that's equivalent to the log of 9 plus the log of 27. Now that's not actually the answer to this problem because my calculator only does base 10, and at the end of this video I'll share with you the change of base rule, so you'll know how to type in something like the log of 9 base 3 can actually be typed in using another rule that we're going to get today as the log of 9 divided by the log of 3. But for this video, the point of this property is if you have a product, you can write it as a sum. So going backwards, if you have a sum, you can write it as a product. So this is going to be the log of 6 times 7, which is the log of 42. And the author agrees. Just remember, this base, no matter what it is, has to remain the same. If they were to ask for the log base 4, if this was base 4 and this was base 5, I cannot apply these properties. So another property is the power rule, which basically takes this exponent and dumps it out front and makes it k times. So for example, this negative 3 can be multiplied out front, negative 3 log 6. Again, I can demonstrate this using base 10, but remember, we're in base A, so I really can't even verify this for you because I can't type in base A, but you can see that the property works in base 10, and I could change the base to base 3, base 4, base 25, and this property will hold true. So for this one, I might want to change this x, the square root of x, to be x to the 1/2. Remember, the base just drags along here. And then I can take the exponent and dump it out front. So 1/2 log x base 4 for a final solution. And author agrees. The next property is the quotient rule, which says if you divide, that's the same thing as taking the difference of the logs. So here's a quotient, and we could write this as the log of 9 minus the log of y. Again, I can't show that to you on your calculators because I can't type the log of y. Your calculator won't do. But we just drag this base along base 3. Author agrees. If you subtract, that's the same thing as division of a log. So there's that log property. Again, I can't prove that to you because we're using base A. Author agrees. So some examples of this that I can't type in because we're using variables is I would take care of this quotient first. So this is really the log of A minus the log of B. So I'm going to treat this as my A term, the numerator, and this is my B term. So the log of yellow divided by pink is really the log of yellow minus the log of pink. But I can simplify this some more because I can use the third property and dump this out front. So it's the log of, or 3 times the log of x. And then this is the product rule. So this is really minus the log of y plus the log of z. And if I distribute that throughout, I get a final answer, log x minus log y minus log z. So just take this slow, step by step. The more work that you can show here, the more lines that you write out. If you try to do this in your head, this might get confusing. You might forget to distribute the negative. So show me lots of steps. So for part B, doesn't look like I created a new slide for that. I will try to do something similar I did on a previous problem where I knew that the square root of x was really x to the 1/2. That's a radical exponent rule where it says if I have base b to any exponent, I could write it as x to the a divided by b. So I'm going to rewrite this as an exponent. This is the log of xy over x to the 7th, all raised to the 1/3. Third property of logs. And the reason why I call it third property is because I've learned them. The log of AB is the log of A plus the log of B. Careful, I just made the mistake that a lot of students make. The log of A plus B is actually nothing. You can't simplify that. So it's the log of AB is equal to the log of A plus the log of B. The second property is the log of the quotient is the log of A minus the log of B. And this is why I keep calling this the third property, because this is the order that I learned them in. The power rule in log A. So 1/3 log of xy over x to the 7th. Now I'm going to concentrate on these products. Well, every time I see a product, that means it's addition. And every time I see a quotient, that means subtraction. So I'm just going to rewrite this as the log of x plus the log of y. And then since I'm dividing, I'm going to say minus the log of x to the 7th. But then I can apply this third property again. So final solution, it's actually 1/3 of all of this. So I need parentheses around this. Log of x plus the log of y minus 7 logs at x's. So what's important here is whenever you see multiplication, just write it as addition. Whenever you see quotients, just subtract off a log. And that's how the author arrived at this answer as well. So let's go backwards. If something is out front, I can dump it up top. And since there aren't any parentheses, it only applies to the first term. If there was parentheses around this, I'd have to put this 1/3 on top of every term, or distribute that 1/3 first. This 2 is going to get dumped up here, so I'll leave this minus the log of y squared plus the log of z. Well, this is a division problem where this is some multiplication. If I would like to, I could even rewrite this or reorganize it. I could dump this. I can just change the order, and I think that brings to life. It doesn't really matter what order I write this in. You can use the commutative property. But no matter, whenever I see addition, this is positive, that answer is going to go up top. So that is going to be x to the 1/3 times z. And whenever I see subtraction in the problem, no matter where it is in the problem, that means division. And I would probably rewrite this as the cube root of x, just to show that I understand that x to the 1/3 is the cube root. Either way would be good, but recognize that x to the 1/3 really is the cube root of x. So another property is addition undoes subtraction, multiplication undoes division. Well, when you stick logs and exponents together, they undo each other. The reason why is because if I use this third property, this becomes k, and then I have the log of a base a, and we learned earlier the definition of logs, which I talked about a fishhook. So if I ever see the log of x, I can set it equal to y and do this fishhook definition. b to the y equals x. So if I were to do the fishhook on this guy, where it says the log of a, base a, is equal to y, then I would say, okay, the fishhook says a to the y equals a to the first, because this term right here is a to the first. I don't see a 1 up here, but it's there. And then I use my one-to-one property and say, well, if a equals a, then this y term has got to equal 1. So that's a nice property to know too. The log of 5 base 5 equals 1. So that's just k times 1, and k times 1 is just back to k. So this answer is just going to end up to be 8. This answer is just going to end up to be negative 3.4. It's kind of like taking x plus 5 and subtracting 5 and just getting back to x. Or maybe even better yet, taking 5 times an x and divide by 5 and just getting x back. Or I could go the opposite way. I could take 5 times x and divide by x and get a 5 back, because multiplication undoes division. 8 and negative 3.4 are author's answers. So here's some big things not to do. I made this mistake once in the video, so be careful of this. The log of m plus n is nothing. It's not the log of m plus the log of n. This actually equals the log of mn. Be careful. Same thing with subtraction. This is not true. It actually does equal the log of m divided by n. This is not true. If it's a multiplication, you can't write it as a multiplication. This guy actually does equal the log of m plus the log of n. And be careful, this is not the change of base rule. They get the second property, the quotient, mixed up with the change of base. This guy in yellow is a property, which I talked about at the beginning of this video. It's called the change of base rule. But this equals the log of m base n, where this over here is the log of m minus the log of n, and those are not equal to each other. So here's all the properties that we have learned so far, just consolidated. And so again, this last one I haven't really introduced, but I think in the next video I will. But it basically says if you have the log of 5 base 3, you can type into your calculator the log of 5 and divide by the log of 3 and get an equivalent decimal for this. So here's all your properties, including this change of base property, which is down here, which I didn't really show you real well on this video. But I hope you found these are the main 3 properties right in here. And don't forget about the definition of logs, because you'll continue using this. The log of x is equal to y when you do this fishhook, b to the y equals x. Alright, I hope you found this video helpful. Email me with your questions. Thanks.